So good afternoon and welcome to the Scripps Technical Forum. I am Douglas Alden. I'm the lead engineer with the Center for Western Weather and Water Extremes here at Scripps. In addition, I function as the STF chair and get assistance setting up and running STF from my colleagues here on campus, Gwyn Nero and Vanessa Scott. Gwyn is the Director of Corporate Affiliates, Business Development, Industry Outreach, and Innovation, and Vanessa is an Industry Relations and Innovation Analyst. If you missed any of our recent presentations, you can find them on the Scripps Technical Forum playlist on the Scripps Oceanography YouTube channel. And I'm going to share my screen. So please know that today's presentation is being recorded. You've all been muted when you logged into the conference. If you have a question for the presenter, please use the Q&A function. And we're going to, Rusty has asked that we withhold the question. I mean, you can put it in the Q&A, but we're going to pick up the questions at the end of the discussion or his presentation. You can, whoops, sorry, touchy mouse. So if you just go into the Q&A, you can also use chat if you have any experienced technical difficulties or anything like that. And at the end, you can unmute if you want to ask something in person, and I'll be monitoring. There's quite a few attendees, so bear with me if I don't see your hand raised or something like that right away, but I'll be watching that at the end of the presentation. So Rustom Jehangir is a founder of Blue Robotics, and he's going to discuss the importance of low-cost marine robotics for ocean restoration and conservation efforts and the communal innovation allowing us to accomplish goals we have not been able to before. So with that, I'm going to hand it over to Rusty, and thank you all for attending.
Thanks for the introduction, Doug, and thank you everyone for being here. I'm excited to talk to you today. I wish I could see all of your faces, but this will do as well, and I'm excited to interact at the end, hopefully, as well. Feel free to put questions in there, and we'll hopefully get to them. So, my name is Rustom Jehangir. I go by Rusty. I'm the founder and CEO of Blue Robotics. Blue Robotics is a company. We're in Torrance, California, just outside of Los Angeles. We have 48 team members right now, mostly in California, but also spread around the world, especially during COVID, we became a little more remote. You can find our website at bluerobotics.com. And our mission is to provide low-cost, high-quality components to enable the future of marine robotics. And so that's what I'm going to be talking about today, a little bit about our story, how we got into that, why I think it's important, and then I'll share how some of our customers are doing really, really cool things in the ocean restoration and conservation space enabled by those components. So let's start off with our story. So this all started back in 2014 with an idea, or actually it's more of a question. Question was, why not make a solar powered surfboard and send it from Los Angeles to Hawaii? It's probably something you ask yourself all the time. My buddy and I had this crazy idea. We'd learned to surf a couple years before. We were both engineers. We both had robotics backgrounds, and we figured it would just be super cool if we could take one of our old surfboards, send it 4,000 kilometers across the ocean with solar panels. Figured that would take 2 to 3 months, be going very, very slowly, but nobody had ever done that before, and we thought it would be really cool. So we started going for it. We started building this thing in our living room. We wanted it to be GPS guided. We wanted to have a computer microcontroller on board to guide it, a satellite radio, solar panels to power it, of course, a compass to guide it, temperature measurements so that we were measuring something useful along the way, and 2 thrusters to propel it and to steer the surfboard moving forward. And so we started working on this. We found all these pieces. It's easy to find a GPS, easy to find an Arduino microcontroller to guide something like this. We even found a satellite radio called a rock block. It's just a few $100s. We could talk to it from anywhere in the world. Bought some solar panels on eBay, had a compass in that Arduino microcontroller, easy to find a temperature sensor. And we got to the 2 thrusters, and that's where we really struggled. There were very few options. We scoured the internet for options, and we basically found these military industrial class thrusters for ROVs and other underwater applications that were like $1,000 to $3,000 each, way out of our living room budget. And then at the opposite end of the spectrum, we found mate ROV teams and high schoolers and college students who are building their own thrusters out of old bilge pump motors from boats and making some hacky solutions that worked for them. But there was nothing in the middle. There was nothing for us that would work to enable this project and help us send a surfboard to Hawaii. We found so many people who were looking for the same thing on online forums and all over the place that we decided to pursue that instead, which started Blue Robotics. So this is our first product that we started with in 2014, and it's a thruster. It's a very simple, basic building block for marine robotics. The one we came up with, we put a lot of work into, came up with a clever, patentable design. Our thruster is small, sufficient, multi-purpose, well documented, and 10 times cheaper than anything else that was out there. At the time, we started selling them for $100 each through a Kickstarter campaign in 2014, and kind of proved out the fact that there was interest in this. We launched this campaign on Kickstarter, raised $103,000, sold over 600 thrusters, and became a marine robotics company. And 7 years later, we're still here. We did end up building the Solar Surfer. This is a picture of it in 2014 with, I don't know if you can see my mouse, but with some prototype thrusters, 3D printed prototype thrusters on here. I get asked a lot whether we finished this project. And so we built the Solar Surfer. We tested it a bunch. We put about 50 miles on it in the open ocean. And every time we ended up getting caught on kelp. We had this big keel. There's lead in this weight at the bottom. The idea being that if it flipped upside down, it would eventually, the weight would flip it back over. But that was also a great way to get snagged on kelp. And so we never made it. We started selling a bunch of thrusters and had to figure out how to provide those to our paying customers. So we put this on the shelf. It's still sitting here and moved on. Okay. So first I want to talk about the importance of marine robotics components to growth and innovation from the perspective that I came from in 2014, in which I'd been working in the drone industry for 3 or 4 years and watched that industry explode. So in 2010, I was in the aerial drone industry. I had just gotten out of college, and it was an exciting place to be. There were like tons of potential applications and benefits for drones. And it was possible. There were affordable core sensors and processing, things that had come out of the cell phone world like IMUs and microcontrollers, hobbyist electronics making that easier. There's open source hardware. A number of companies came out with open source autopilots for these drones. So open source software driven by that same community that made it much easier for somebody like me to get started. And I think thousands of other people to get started. And what that really led, and last, there was an abundance of affordable drone components, primarily because there was a remote controlled RC airplane industry that had been around for 30 years already. So on day one of going into this aerial drone industry, you could buy propellers and motors and airframes and landing gear and servos, and all of the raw materials to build a drone just existed, and they were really affordable because they were designed for hobbyists. So when you put all those things together, we got a drone industry boom, very high accessibility. We went from this only being a military technology to now you can go to Best Buy and you can buy a drone that can do amazing things, create amazing videos, has all sorts of applications in a very short period of time, I think enabled by this. In comparison, we look at the marine robotics industry now, and for the last 5 or 10 years. So there's also many potential applications and benefits, lots of exciting things. I think if you're here, you can probably imagine the cool things you can do with marine robotics. We also have very affordable core robotic sensors and processing. We have mature open source hardware and software from the drone world. But I think we have a severe lack of affordable marine robotics components and sensors. And so if you're somebody like me who wanted to build a vehicle like the Solar Surfer, and you go in and you find out that you're gonna have to spend $6,000 just to get motors that'll last in the ocean, you're probably just not gonna do it. You know, that's gonna stifle innovation. So it leads to slow growth, leads to limited accessibility, and that's what we at Blue Robotics are trying to change. So I want to show you a little bit about what we've become over the last 7 years in trying to accomplish that mission. I'm going to focus on some elements of our business that I think have kind of become unique things to us that are also very important to our customers, things we really care about in our business. So first of all, we realized that after thrusters, people need more things. Next, they need enclosures, then they need sensors, then they need cables. And so we've produced a wide range of modular, flexible, and enabling components. That started with the thruster. We added electronics to communicate with an ROV. We added a series of watertight enclosures. This is an underwater cable penetrator to make it less expensive to pass a cable into an enclosure. Pressure sensors, temperature sensors. This is an echo sounder sonar. Neutrally buoyant tether cable, underwater lights, batteries. This is a circular battery to fit in a typical underwater housing. We even sell this underwater robotics textbook, which we found was hard to find even on Amazon, to help give people accessibility to that. And all of these components came together, and in 2016, we released this product in the center, which is called the Blue ROV2. It's a remotely operated underwater vehicle. And it basically uses all of those components that we had built up over time. There's 8 thrusters on here. There's 2 different sizes of enclosures, lights, electronics, the tether cable, all of those individual pieces, but they can all be used individually for other applications as well. I want to show you our newest product right now, mostly because we're really excited about it, and I think it fits into this model pretty well. It's called the Wet Link Penetrator. And this passes a cable, like you can see on the right, a cable into an enclosure. It's a little O-ring here to seal that against the enclosure. And with this device, we have no potting compound. It's easy to assemble, just takes a few minutes. It has a 950 meter depth rating, and very, very low cost. It's about $12 each for one of these units, compared to, I think last time I checked, what a subcom connector set costs. It's about $150. So 10 times cheaper to pass a cable into an enclosure. We've launched one size of this so far this summer, but we're making a full product range for 4 to 9 millimeter cables to enable lots of different applications in marine robotics. All of these products here, we shoot for very, very affordable prices. So the thruster right now is about $179 compared to the original $900 to $3,000 price that we found for thrusters. Our enclosures can be configured, but are usually between $120 and $300 compared to what else I can find is $600 to $6,000 for similar sizes. This Wet Link Penetrator is $12 compared to the price of an underwater connector set. This echo sounder is about $300 compared to our market survey found options between $600 to $8,000 for similarly performing products. The light's $129 compared to $600 to $3,000. So you can see all of these price points are wildly different than what was previously out there, including on the ROV. Starts as low as around $4,000, can be configured up to $7,000. And if you're familiar with the ROV market, it's very easy to get an ROV this size and capability to cost way more than your car. So this enables a lot of people to get involved. One of the most important things to us, and has been important since the beginning, is sharing information about our products as clearly as possible, having open information. So this is an example on our thruster. We have very clear specifications. We have performance charts. We have 3D models you can download to integrate into your application, have dimensional drawings. This is something we really couldn't find on existing products at the time. It's just another barrier to people using our products. If you have to sign an NDA to get a CAD model or talk to a salesperson to even find out the price, it just slows everything down. We also leverage a lot of open source software, a lot of it coming from the drone world. One example of that is ArduSub here, which is based on the Ardu pilot project, which is one of the most mature open source autopilots for drones. And we use a branch of that software that we maintain to control ROVs. And it's worked out really well, gives us access to hundreds of other developers working on this code around the world to make it better, and contributes to the underwater version of that. Similarly, on the top side, we use a software called Q Ground Control. It's originally a ground control software for drones, but works great for ROVs too, and gives us a lot of capabilities right out of the box. There's lots more. For all of our sensor products, we've got libraries, we've got code examples. We try to make all of that as accessible as possible. We don't sell any software at all, we just sell hardware. Next, we have a community of people, an online community, which seems to be pretty rare in the marine robotics world. This is a snapshot of our forums, where you can see got a bunch of different categories here. Some deals with the support of our products, but there's also a lot of people just sharing their dive logs, or asking questions, or working on cool projects. This is an example from one of our friends up in Santa Barbara who posted about a wreck that he dove on recently, shared the video, got a bunch of questions, got more people involved. And this happening on a daily basis is really cool. We connect people from around the world, and they share a lot of their inspiration and ideas. And then last, we've got worldwide value-added distributors. This map here kind of shows you that the interest in marine robotics is all over the world. We've got about 50 distributors. They're really important to us and help us make this more accessible to people who speak other languages, are in different locations, have different locality-specific applications, etc. So some facts from that. 7 years later, we sold 600 thrusters in our Kickstarter campaign. We've now sold more than 60,000 thrusters. We've sold over 2,600 of those Blue ROV2 vehicles. And we have 220 products in our store, and all of them have been fairly popular. 70% of our orders ship outside of the USA, which I think is always an interesting fact. We've got 50 worldwide distributors. We have 4,300 repeat customers to our online store. And I guess the point with all these numbers is just that there's a lot of interest and a lot of growing momentum in low-cost marine robotics. It's a lot of opportunity here. So next, that's a little bit about us. I want to talk about what are all those people doing with this stuff, you might be wondering. And there's lots of applications. We sell lots of stuff to businesses, lots to aquaculture, inspection, university, students, research, all over the place. But today I'm going to talk about some stories in the restoration and conservation area, because I think those are particularly cool. So I'm going to start off with ocean and waterway cleanup. Something you see in the news all the time. We obviously all understand the importance of that. This is a video here from a customer. This is a young company, young startup company, a couple of people just out of school who are trying to create a vehicle, much like our Solar Surfer, but this one's intended to clean up the oceans. So it collects in trash, brings that to somewhere where it can be dumped. Very cool application. And this is using a couple of our components. It's using our thrusters, some of our navigation, open source software, and it enables them to do something like this pretty quickly, make a prototype quickly. This one's cool actually, because we met another company a few years ago who's doing something very similar. They're in the Netherlands and called Ran Marine. They've been working on this for about 5 years. They've got this vehicle called the Waste Shark that is intended to do a very similar thing. They're also using those same thrusters to propel it, and you can check out what that looks like here. If you think about the scale of cleaning up the oceans and every lake, pond, waterway that has trash in it like this, it seems obvious that you need low-cost robotics to do that. You can't do this with $100,000 vehicles. You have to do this with very low-cost, affordable vehicles. And the way to get there is by having low-cost components and technology. There it is, full of trash, ready to be cleared out. All right. Next up, we've got a cool story from one of our customers in Canada who's doing ghost gear cleanup. And if you're not familiar with ghost gear, it's left behind fishing gear like fishing nets, crab pots, lobster traps. And there's just huge amounts of this out in the ocean. I'm gonna let them explain here. This is a pretty cool video. It's about 2 minutes long, but I think it's worth watching that.
We put the ROV down, and as the ROV went down the anchor line, it discovered the drag marks in the sand, and then looming out of the darkness came these images, almost looked like the Titanic, of the stanchions sitting about 1.5 meters off the bottom of the ocean.
Shipwreck diver Tony Sampson and his crewmates didn't find the Titanic wreckage. They didn't find buried treasure either, but they did find someone's trash, abandoned or lost fishing equipment known as ghost gear, spread over a 600-meter watery grave.
We worked out that this was actually ghost gear. So we did a dive. Then when we attached gear to it and started hauling, we had no idea that we were going to bring up 4 tons of anchors and 3 kilometers of line.
The unusual catch brought ashore in Mahone Bay, not far from where it was found. It took a team effort by this Titan Maritime crew to haul in all the garbage.
So when we got one bag of sand up, then we'd have to go to another rope because we didn't want to lose it again. So we had strings all over the boat.
But this was no fishing expedition. The Canadian Hydrographic Service, which spent 7 years mapping this area, provided detailed images to the crew.
Keep it coming, buddy.
And they had an ROV customized with extra bells and whistles just for this quest.
Ghost gear recovery, if the lines get caught underwater, I can remotely cut the lines.
Fishing gear entanglements are a major cause of death for endangered North Atlantic right whales. In response, the federal government set aside $8.3 million over 2 years to fund ghost gear retrieval and innovation projects. But so many proposals from companies came in that all of the money was handed out in the first year. The Titan team didn't have federal funding, but they went ahead with the cleanup anyway.
This here, to pull this off the bottom, it not only gives us a warm sense, but it's doing something for the environment here.
All right. Okay, so thanks for watching that. I think shows a little piece of that can be enabled by robotics here. And I also think this one is a particularly good example of this vehicle here is taking advantage of the flexibility and modularity that our products have. The thrusters are moved to a different location. It has added sensors. It's got added electronics down the bottom. They've taken full advantage of flexibility to make this vehicle suitable for their application. That guy mentioned that he's got a cutter on there to cut ropes. I think they actually built that themselves to handle that application, which is very cool and highlights how enabling tools, low-cost tools like this can open up new applications. This ghost gear fishing problem is a big enough deal that, like I said in the video, there is federal money available as part of Canadian-American collaborative fishing agreements. I hope that continues to grow. Next up, I want to show some projects on invasive species mitigation. These are particularly cool, interesting applications of robotics. This is Matthew Dunbabin from the Queensland University of Technology in Australia. And the vehicle he's next to here is called the Cotspot. This is from a few years ago. This is their first prototype of a vehicle to address the problem of invasive crown of thorns starfish in the Great Barrier Reef. You can see a diagram of the vehicle here. This is in, I think, a Popular Science article. And this robot actually has a robotic arm on here with a little needle at the end, and it can inject a crown of thorns starfish with a lethal toxin. Basically, pick it out on the reef, inject it, and kill it. Pretty crazy. It's got computer vision that guides the AUV around the reef, identifies targets. That his lab has put a ton of time into that navigation on the reef. They don't use any fancy, expensive sonar or anything. They just use computer vision to navigate and find these targets. And it's designed to be scalable, and it's designed to be low cost to allow a big impact. You can imagine, again, you can't do something like this and have a meaningful impact if you have $100,000 vehicles. You have to make it much less expensive and much more scalable. Here's another similar one. This one is from an organization called Robots in Service of the Environment. These guys are operating in the Caribbean, where there's an invasive lionfish problem. You guys have seen these, probably seen them in the aquarium store. They've taken over a lot of the Caribbean. They aren't afraid of anything. They'll eat whatever gets close to them. And there's a big, right now divers go out and try to collect these, but there's a lot of limitations there. That divers can't go very deep. They can't stay out for very long. It's not necessarily economically viable to do that. And so this organization has built this ROV, again, leveraging lots of our components, but repackaging them into a new useful design for their application. And this actually has electric plates that stun the lionfish and then suck it into this custom-built lionfish vacuum in the center. Got a quick GIF of that happening. Pretty wild. So you can imagine that happening at a larger scale and helping to address that problem. Again, enabled by lower cost components. I'm going to jump back to Matt Dunbabin at the Queensland University of Technology. This is the second version of that COTSBot vehicle. They changed the name to RangerBot and made a bunch of changes. They switched to stereo cameras in the front, added more lighting, changed the thruster configuration, made it a little bit more capable and maneuverable. And so they took this same vehicle design and they're now using it for coral restoration instead. They actually, they're able to disperse coral larvae onto the reef to replant areas of the reef that have been bleached and killed. Again, doing a very cool application with robotics here that wouldn't necessarily be scalable with human divers. And the last section here, I'm going to talk about a few research projects. Could talk about these all day and find lots of examples, but I'm just going to show two here. So this first one is at the Schmale Lab at Virginia Tech, which is studying how harmful agents disperse in the water. And in this case, they're using a harmless dye in the water, and then they've got a Blue ROV2 equipped with a fluorometer that can measure the concentrations of that dye in situ as it's dispersing. They've also got a drone above, obviously, that took this photo and is able to record data as well. I think this is a cool application. This helps a lab like this have another tool in their tool belt when they're running these science experiments that may not have been previously available. And then last one here, one of my personal favorites. This is from Applied Research Associates, I believe in Colorado, and they've been doing work studying how burning oil spills disperse. And they use this ROV here to measure the thickness of an oil spill from underneath with sonar technology as that oil spill is burning. They did these trials over and over and over again. It's one of the crazier ROV applications that I've seen. And I think, again, the technology here, the low-cost technology is enabling new experiments, enabling us to study new things. And I'm just showing you a little snapshot here, but you know, there are hundreds or thousands of people finding unique ways to use this technology. And we want to enable that. So on the right here, I've got a clip. This is just from Instagram. Good news movement. This is like mainstream media. You know, what people find on their feeds every day, showing up on their phone. And this is a story of a turtle getting trapped in fishing lines, I think, and getting rescued. And the point here is that these are the kind of stories that people are seeing every day. This is what people who are growing up and interested in the ocean, this is the kind of information they're seeing every day. And so they're developing a desire to take care of our planet. And it's at the forefront of their priorities. It's something they care about. You can see this video has 600,000 views. Obviously, people are very interested in this. They're very interested in solving this problem. And I think that's only going to continue. So as people want to continue solving these problems, they are going to need low-cost technology. It's going to be one of the tools that helps us get there. So I encourage you all to think about how in your own work you can take advantage of low-cost technology, what solutions that could open up for you in your future work, and how you can contribute to helping make that available for everybody here and for the next generation who's working with these problems. So that it's the main part of my talk. when you guys were signing up, you had a lot of questions that you asked in the sign up form. And so I've got some specific answers to those, and I'm going to start off with those, and then we can jump into any questions from the audience if there are any. So first one here is, how can we facilitate the use of ROVs for citizen science data collection? It's a good question. It's a hard question. So to me, one of the most important things here is to share what you're doing and share with the world. We need to inspire and educate the people around us. They need to see what sort of things are possible. They need to see that marine robotics exists. They need to know what an ROV is. They need to know that this science is happening and can do something cool. And the only way for them to find that out is to share. So I encourage you all to just share what you're doing and get it out there, inspire others to do the same. And next, we need to reduce knowledge barriers. We need to make it easier for the average person to get involved in marine robotics, to use marine technology, to study the oceans. There's a lot of ways to do that with products and making them less expensive, but there's also a lot of ways to do that by reducing knowledge barriers, by educating people about it, making them familiar with it, making them care about the mission and the science that can be accomplished with these products. Second, I think it's really important to support companies and projects that enable citizen science. A lot of them start small and they grow bigger, and they might not be a good fit for you when they're small, but as they grow bigger, they could become a good fit. I think we're a good example of that. We started off with a small product line, but as we've grown, the capabilities have expanded, and it's applicable to more and more projects. And then last, I think this is something that I don't know how to solve, but we need places to share the data that citizen scientists collect. That's definitely a huge challenge, but sharing that data and making sure it gets to useful, meaningful places is difficult. Okay, the next question here, this is a fun one for me. This is how will low-cost components keep up with performance needs? So here I think low cost to me doesn't always mean low quality. And so I think low cost disruptors get better over time. So people come in with a new crazy idea, they come in with a minimally viable product, they get that out the door, they get a little bit of interest, but over time they're able to mature that. And then as you get to higher volume, which usually happens with lower cost, that also changes the equation. I think an example for both of these is our thrusters. So as in 2014, we were a disruptor making a $100 thruster. And like, I'll be honest, at the very beginning, the quality was not very good. Our design was new. We didn't know what we were doing, had no idea how to manufacture things. There were lots of problems, but we changed that over time. Every year we've made the thrusters a little bit better than they were the year before. And now they're really awesome, extremely reliable, working in all these harsh situations around the world. So those products can get better, and the price really hasn't changed that much in that time. And then on the higher volume end here, this one is important for low cost. So before we came along, the most important company in the thruster industry is called Technodyne. They're in San Diego. And if you go to their website, up at the top, it says, we've sold 8,000 thrusters since 1985. And right now we're selling 8,000 thrusters every couple of months. And that totally changes the equation. The amount of attention that we can put into those thrusters when that low cost enables high volume is much higher. So they can still be very high quality, very high performance, high reliability. That low cost enables more people to be interested and just changes the situation. So I definitely would not always equate low cost with low quality. And second, I think like most industries, competition will encourage continual progress here. Technology always improves, not independent of price. Your computer, your phone, they all keep getting better without them costing a proportionally different amount. An example of that here for us is our new cable penetrators that I talked about at the beginning. Our previous cable penetrators usually only worked to 100 to 300 meters. They weren't as reliable. And this new one is about the same price to the end user, but works to 950 meters, validated to a much, much higher level of reliability without affecting the price, still pushing the industry forward and the performance forward. So I want to share a quick picture here just to illustrate that. So this is our T200 thruster production line in 2015, March 2015. This is my garage at the time. And I got surfboards, some RC airplanes, it's a total mess. This table is where we were building thrusters. It's building them on the weekend with friends. And so this was a starting point for a disruptive technology in this space. And here's our thruster production line today in 2021. It's much bigger now. We've got 5 or 6 people working just here. We have manufacturing engineers who spent years in the automotive world. They know how to manufacture things. And so everything has changed. And the product still looks very, very similar to the way it did at the beginning. It's a similar price, everything, but what's behind it and backing it up and the quality and reliability that are part of it now are dramatically different than they were 5 or 6 years ago. And I think that will keep happening. And the performance level of low-cost marine robotics components will keep going up. All right, next one is, what are ways that companies can work together to help make the ocean more accessible? This is a challenging question as well. But my first answer is to, again, share. Same bullet points here. We need to inspire and educate. Companies can work together to do that. You can share what another company is doing. Just share cool news that's in this industry and further reduce knowledge barriers, get more people familiar with it, more people excited about it. And then next we can collaborate. Of course, lots of ways we can do that. I think one of the things that we've learned is that sometimes the benefits of collaboration may not be directly financial benefits. So you're not necessarily going to make a cut of the product you work on with somebody else that you collaborate on, but there's a lot of other benefits of working together. There's the knowledge you gain, the mutual knowledge you gain. There's shared marketing value, reaching out to new people, new industries, crossing interdisciplinary lines. So I think it's always worth trying to collaborate regardless of the financial situation. You also need to think broadly. There's a lot of very specific solutions in marine robotics, but I think often what you're working on in one space might be really useful for someone else in their project. And again, you have to be sharing here. You got to put your projects on Instagram or on an online forum so that other people can see what you're doing to find that out. But that's often the case. And sometimes if you're someone here who is developing products, sometimes I think we need tools rather than solutions. This is definitely a focus for us. We're not making specific solutions we're not making a way specifically to collect ghost gear, but instead we're making a tool that enables that company when they have a need to address that problem. But the same tool can be used for many other different situations. I think in this industry, there's still a big need for those tools, those raw parts, raw materials to enable others to create solutions. And last, you need to be an advocate and help everyone in this industry be successful. This is something that we try to do really well. If you look at our social media, we're mostly sharing what other people and companies are doing because we think it's awesome and we want to promote them and help them out as well. And I'd encourage you to do the same there. Next question was, what are the current industry roadblocks? And I'm not going to answer this one directly myself, but instead I'm going to share some results from a customer survey that we did just a couple weeks ago. We had about 175 respondents to that survey, and we actually asked this question: what are the biggest challenges or barriers for you in marine robotics? And so I'm just sharing the results here. The x-axis is the number of respondents who chose that option. They could choose multiple options here, and then sorted by the ones that are most important. So for most people, the biggest challenge is that it is still too expensive. I think we could have guessed that. The next one here is that accessories, tools, or sensors are not available. I think that points out that there's still a lot of room to improve the types of tools, sensors, accessories, all of the products that are in marine robotics. There's a lot of room to continue improving that and opening up people's applications and enabling their ideas. The next one is that my needs are too unique and nothing exists. Kind of fits with that last one, that the products they need don't even exist yet. Then there's steep learning curve. The products are not reliable enough, products are not capable enough, and it's hard to convince the team or management that we should be using robotics instead of divers or, you know, remote sensors instead of sending somebody out to do it. So I think this is interesting and points out that there's still a lot of room and a lot of interest in low-cost marine robotics and in this space growing. And I believe that is actually it. So at this point, I want to see if there are any other questions from anyone in the audience.
We had one come in, and that was, are you building all components for the thruster yourself? Is the motor something that you produce?
Yeah, good question. So we do produce everything, but we use a lot of outside vendors to produce raw materials. So the thruster is made of injection molded parts. We don't do any injection molding here. We do that. We have somebody else do that, and they send us parts. The motor we designed, but we have the motor wound. We have the magnet rotor manufactured elsewhere and brought here, and we do the final assembly. And we found that that's the best combination of ways to do things that allows us to move pretty quickly to keep the costs low, because we can get parts from low-cost suppliers who are really good at injection molding or motor winding. We don't have to become competent at those ourselves. And then we still maintain a lot of control over the final product and the quality of that product. Every one of them goes through our hands. Everyone is tested. Everyone is assembled here. And that allows us to be agile. If we find a problem, we can fix it quickly, and allows us to expand our product line quickly as well. Good question.
Yeah,
Is
so
there anything else?
Yeah, the next question is, can you talk about some of the new products you're working on?
Yeah, I can definitely do that. So you guys probably have this problem as well. We always have way too many projects going on at the same time, and you know, we get excited about all of the possibilities. We start working on everything at once, and so it takes a long time to get through new product developments. There's a couple of projects we're working on right now that are most important to us. The first one is that we're making a larger thruster. It's called the T500 thruster, based on the very similar design to our existing thruster, but it's one of the things that our customers have asked for the most. We've been working on that for years, but we're getting close on that one. And other than that, we have a lot of projects. I'm not going to talk about all of them, but I can tell you that as a company, our direction is going to continue being down the path of creating enabling components for our customers, hoping that our customers will take our components and do really cool things with them. They're designed to do things that we never anticipated. So I hope you will continue to see our product line expand and enable more cool applications. Sorry if you wanted more juicy details than that.
So we got another one, which is, what is the full power consumption for the Blue ROV, with it running at full power with lights and cameras working?
Yeah, so that's a tough question to answer for an ROV, because most of the time with an ROV, you're not driving at full power all the time. So if you do drive at full power, the ROV can draw anywhere between 1,000 to 1,500 watts continuously, which will drain the batteries quickly. That takes a lot of power. But in a typical ROV application, you're not doing that. You're sitting still, you've got your camera on, you're maneuvering around a little bit. So we tend to find that with one battery, the ROV lasts for about 2 to 3 hours in most applications. Hope that answers that question.
Okay, so the next is, where are you hoping your company service to be in 5 years? What component product do you expect to be making the most of?
Good question, big question. So I think, to me, I think we'll still be, well, like I said, we'll still be focused on enabling components. We'll probably have a few new systems in our product line as well. And I think the thrusters will continue to be our bread and butter product, because they're really just a fundamental building block of marine robotics. They're one of the first things that anybody building any sort of vehicle will need, and they tend to need a lot of them. Most ROVs have 4 to 8 thrusters. and they're difficult to build at low cost without doing that at scale. Let's see, other than that, I think there are a lot of opportunities for expansion of watertight enclosure options, underwater connector options, underwater penetrator options, sensors and sonars. Like you can pretty much look at any product in this industry, and there's big possibility of making it less expensive and opening up new applications for it. We'll definitely be pursuing some of those things, and hopefully those will be some of our big product line additions as well.
Next question. Are you planning on having a European Union office for development?
We don't plan on having an office there. We have, like I mentioned before, we have 50 distributors around the world. And most of those distributors are, they started off with just 1 or 2 people who were enjoying using our products, and they decided that they wanted to turn that into their full-time job, and they saw a need for it locally. So for instance, in Norway, we have our distributor JM Robotics. They've had a background in aquaculture, saw the potential for low-cost robotics in that space, and they've been very successful doing that. They have a whole team of people now, and they've grown an organization that's using a lot of Blue Robotics parts in Norway. And that story can be repeated around the world. We've got distributors on every continent, almost. And if you're interested in working with one of them or working for one of them, I'd encourage you to check out our distributor map on our website and find somebody locally who's working with our components, working in low-cost robotics. Encourage anybody to get involved. Good question.
All right, I think that's the end of the questions that I see, and I don't see any hands raised or anything like that. So I just want to thank Rusty for his time today, and it was a great.
Doug, can I say one more thing?
Sure.
Okay. Okay. I actually have a question for all of you. I know I can't get an answer from you here, but I'm going to ask anyways, and then send an email out to see what you think after. So this was inspired by one of the questions that an audience member asked that I still don't have a great answer for. So my question is, what can the marine robotics industry do to better support and enable marine research and citizen science? So I have everybody's email addresses here. So I was going to send out an open-ended survey form after this, and I would love to hear from you on this question. I think it's interesting, and this audience is particularly relevant to answering that.
That's an excellent idea.
Back to you, Doug.
Yeah, excellent idea. Really interesting products. I think there was one other thing that I was looking over at the list. I mean, there was a question about the transducer portion of the ping sonar altimeter and echo sender, and whether they could be purchased, just the transducer.
Yeah, so I'll step back a little bit and just say that one of the cool things about this industry is that everybody has custom needs, because everybody's doing something different. And to us, it's really cool for us to have distributors, because each of our distributors around the world is able to customize our products for the local needs. There's a different ROV configuration for aquaculture than for inspection than for research. So we get a lot of people asking to buy individual parts or components, and as much as possible, we try to service those requests and help those people out. So if you ever have a need for that, please feel free to email our sales team, and we'll try to figure that out.
Great. Yeah, and there was one other one that caught my attention, which was about if you're tethered, are you able to see everything in real time, or do you have, like, if you're recording video cameras, or is that something you have to data dump at the end of the mission?
Yeah, so on the Blue ROV 2, like most ROVs, you've got a live camera feed coming back to the computer screen in front of you. Once you're a couple meters underwater, you can't see the vehicle at all anymore. So the only connection you have to it, and the only way to control it, is through looking at that camera. On the Blue ROV 2, we use a laptop on the surface, and we use an Xbox controller to control it. So you've got an Xbox controller plugged into your computer. You've got the live view up on your screen, and you can see everything happening in real time as you move it's basically like playing a video game. As you move the control sticks, the ROV is driving around underwater, and you're getting instant feedback, as well as recording the video and data for later.
And how much bandwidth is the tether capable of? I mean, and what percentage is just the basic ROV? I'm just thinking about if you're adding sensors, how many sensors could you add to that data stream and still have a functional system?
Yeah, so the ROV basically has an Ethernet connection to the surface, like 100 megabit Ethernet connection. Over longer tethers, that can get a little slower, but it usually doesn't get any less than about 40 to 50 megabits per second, which is plenty for multiple video streams, lots of data, sonar data coming back. And once you become an autonomous underwater vehicle, everything changes, as many of you probably know, and then you have very limited communication with the vehicle, and very little way to get data back quickly. But on ROVs, you have a lot of connection with it.
Yeah, one other thing that jumped out at me was whether there was the possibility of underwater wireless communication. I don't know if that's something that you guys are working on or thinking of.
Yeah, I can talk about that. So that's not something that we're working on specifically, but there are a number of companies working on reducing the cost of doing that. The two main options there are acoustic modems, which communicate with sound waves. They have generally very limited bandwidth, so you can't send video, you can just send some data. And then there's also optical communications underwater where you're using lights, like flashing lights, to send data at a much higher rate. Those can go shorter range, but can often enable wireless communication. There's a company called Hydromea in Europe that is doing that, and I think some of our customers have used that to make their Blue ROV2s wireless, which is pretty cool. It's nice when you don't have to think about your tether. Good question.
Nice. Well, thank you again. Appreciate everybody's input and joining us today. It's one of the higher attendance counts for our STF. I think there's a lot of possibilities with this low-cost system, and look forward to seeing what the future holds.
Great. Thanks for having me here, Doug. And thank you, everybody in the audience, for being here. I really appreciate it.
And I'm just going to mention that August 9th, we have Santuc coming up. And then on the August 23rd, we call Concord Marine. And if you have any questions about the forum, or if you want to pitch some other ideas, just send an email to me, Gwen, or Vanessa, and we'll take care of you. And with that, thank you, everyone.
Thank you.
See you.